Good day. My name is John Vincent S. Taracanlao. You can call me Sir John or Dr. Taracanlao. So, previous lessons we discussed on mean, standard deviation, and frequency and percentage distribution. I hope you were able to practice on those statistical concepts and tools on your on any data you have, whether it's example or real data you have. So what we have now are, okay, this is just an example on table setting for descriptive statistics. Remember, it varies institutionally, but the relevant information are usually here. So table one, distribution of respondents according to level of satisfaction. That's your heading or title. So you have level of satisfaction, you have very satisfactory, fair, poor, and very poor. In this and you have your thresholds also, your scoring, and you have your frequency and percentage distribution. You also have your mean and standard deviation. Always remember that these parameters for standard deviation is very important. You have a number, it's calculated, but if you don't know what it means, then it's useless. So, for example, stating and finding expectation in this example, the data shows that majority, 58%, satisfaction is poor. The overall rating, which is the mean, it's 3.44, so it's between here. It's also poor, 3.44. The standard deviation of 0.81, which means that their responses vary from each other. So from that alone, you can already have insight. The standard deviation that says that vary a lot from each other, you can add inputs like there are actually not a substantial percentage of respondents whose satisfaction is satisfactory, and you also have poor. So it doesn't mean that since the majority and the overall rating is poor, then we should not consider the other responses also because it's there. There are frequencies, actually a couple, uh, a number of frequencies that says that their level of satisfaction is satisfactory, fair, and poor. And that's how important standard deviation is when you when you describe your data. Unless the data says it's very close to each other, that in a sense we can say that all of them are poor. So restriction and insights, very important to limit your insights on the result. Do not correlate or relate with other variables, especially to the dependent. So when you discuss it as it is. Do not correlate because let's say level of satisfaction. This is a general overview of the level of satisfaction. It does not correlate with their other variables like gender or ethnicity or attitudes. So discuss within the table. Do not correlate or relate with other variables because it's not there in the first place. Next is, yeah, that's it. So I hope you're, as I said, it varies institutionally, but you can always use this framework, this sample to set your findings. So we'll also be discussing different statistical concepts, but it's not, it's rarely used in presenting data from descriptive statistics, but we still have to understand those concepts. Okay, so we have variance is the square of the standard deviation. So this is standard deviation, you square it, that is your variance. You have median, another measure of central tendency. It divides an order set into two equal groups. Half of the number will have values that are less than the median and half of the values greater than the median. For example, if we have 7 boys with marks in English of 28, 31, 27, 45, 43, 52, 38, then the median mark obtained by those voices can be found by ranking the marks and taking the fourth. So, figure in order to magnitude example, in order of magnitude 27, 28, 31, 38, 43, 45, 52. The median will be 38 because here it's 1, 2, 3, 1, 2, 3, and that is your median. For example, we have 5, 6, 7, 8, 9, and 10. So we have 3 here and 3 here. So your median is between 7 and 8. So median is 7.5. Yeah, I think that's easy to understand. Mode. Mode. The mode of the set of numbers is the value which occurs the greatest frequency. More precisely, it is the value of a variable at which the concentration of the observation is the densest. It is possible for the mode to be non-existent in a series of numbers or to have more than one value. For example, we have 5, 6, 7, 8, 8, 9, and 10. So your mode is at 8. So we have class size and class limits criterion. So response. Oh yeah, I already discussed this one. So class size, class limit is n minus 1 over n. So 4 minus 1 over 4 is 3/4, which is 0.75. So your class limit is at 0.75. So 1.75, then so on and so forth. 0.75. Let's check that out. So we have um, 1 plus 75 equals to, okay, and it's going to be plus 1 because we will start it with 176. So equals to, okay, and 252 plus 2 plus 0.75. Okay, and 3.28 equals to 6 plus 0.75. And but our highest limit is only 4, so you just put it at 0.4. That's the classes and limits in terms of criterion. Now let's look at class limits by norm. Remember, criterion is has a 0 point, the lowest value and the highest value. And now we have the norm. Remember that criterion, we don't have the data yet. But in the norm, we already have the data. I think you all understand the difference between projecting data and calculating them and doing a norm with a specific set of data, then setting it as it is. So we have class limits are the smallest and the largest observations, data, events, etc. in each class. Therefore, each class has two limits, a lower and an upper. So we have 200 to 299, 300 to 399, and those are your classes. Using frequency table above, the what are the lower and the upper class limits of the first three. So for the first class, we have 200. That is our class limit, lower class limit, and the upper limit is 299. The second class is 300, and you have 399, and so on. So that is class boundaries. Class boundaries are the midpoint between the upper limit of a class and the lower limit of the next class in sequence. Therefore, each class has an upper limit and a lower class bound, has upper boundary, upper and lower class boundary. For example, uh, For 200 to 299, the class boundary is in the midpoint between 195, 199, and 200, which is 195. And the upper class boundaries is midpoint between 299 and 300, which is your 2995. So this one and 300. For this one, between here is the limit. Class boundaries. It's the point between each side. So you are here, that would be 199.5, and your class boundaries here is 299.5. Here, 299.5, 399.5, and so on. Yeah. But the Excel and other calculating devices will automatically count them. Well, when you input the data and there are certain decimal points, Excel and other calculating devices will paste them accordingly based on the decimal point that is given, and they will just round it up. So no worries about class intervals. So class intervals is the difference between the upper class boundaries of any class. Using the table above, determine the class intervals of the first class. So the first class is 299 and 200 and 299. The class interval is the upper class boundary and the lower class boundary. So the upper class boundary is 299.5 and the lower is 199.5. So just uh, minus them and you have your class interval of 100. Yeah. Cumulative frequency is obtaining by adding each frequency in the table to the cumulative frequency in the row above. So if we have here our frequency is 3 and our cumulative frequency is 3. And for the cumulative frequency of the next score, that would be 3, the cumulative frequency of the first, plus, no, yeah, the cumulative frequency of the first, plus the frequency of the second. So 3 plus 5. And next is you have the third. So you have 8 plus 9, then 17 plus 10, and 20, then 17 plus 10. Then you have here 27 plus 11, and that's 38, and 38 plus 9, and so on and so forth. So, and that's how you get the cumulative frequency. It's just adding the result with the next frequency. Next is charts and diagrams. So, line diagram is this method of representing discrete series graphically in a line or a bar. And histograms, polygon frequencies, and frequency curves. Uh, there's no specific type of charts or diagrams that best represent a data. You have to choose which one is appropriate or best describes or best illustrates the data that you have. So it's more of creative and the technical aspect in your part to make sure that the presentation of the result is clear. You can use this one, any of these, but what is important is it's comprehensible and clear. And that is already in graphs using Excel. Just highlight the data in the chart and type of chart you want to use. Next is yes. So that is our lesson. Yeah, just statistical concepts. And we have here a summative one. Yeah, I guess we finished with descriptive stats. And those are the necessary, no, important statistical concepts in descriptive statistics. And some of them are not even used. Okay, so moving on, we have here, oh yeah, in descriptive statistics. So I'll discuss this now. So activating analysis toolpack in Microsoft Excel. This is very important because you can do a lot of this when you have this activated. By default, it is not activated. So we need to activate that one so that you will be able to access calculations that are not set by default. So let's go to this one. Okay. So first is activating analysis toolpack in Microsoft Excel. So you go to File, click on File, look for File or Microsoft logo and look for options. So you have File or the Microsoft logo and look for options. Next is you click on Add-ins. Add-ins and select Analysis Toolpack there and click on Go and Manage. Go. Once you're there, just click on Analysis Toolpack and click OK. You also have other tools there, but Analysis Toolpack is already good. Then OK. And then click Data, and look for Data Analysis. If you're able to do this, then you have successfully activated the data analysis button for your Microsoft Excel. And you will have here different statistical concepts and tools will be discussed later in, upcoming videos. We have ANOVA, correlation, covariance, descriptive statistics, exponential smoothing, access for your analysis, histograms, everything. We'll be using, I'll be teaching this, regression, uh, descriptive stats, also correlation here and this one, and single factor. This will be discussed in upcoming lessons. Of course, we're now shifting from descriptive statistics to inferential statistics. So, yeah, I hope you learned something from today's video. This is very important to do the analysis toolpack so that you have data analysis in your computer, and it's free and it's just with Microsoft Excel. Yeah, uh, that's it. So I hope you learned something today, and hopefully purchase the book once it is released mid-February and February 2024. And you have a good day. Message me if you need some help or no comment on the section bar or something. We'll find a way to communicate. We'll find a way or a platform that we'll be able to communicate with each other. So I guess that's it. And have a great day. Bye.